everyone. We are a group of three members, myself, Neha, Mohana, and my friends are Tribhuvana, Sai Sreevardhan, Veduri. Today we will be presenting on sentiment and emotional analysis for information retrieval. In this session, I will explain how understanding emotions in text can make search systems and information retrieval tools more intelligent, more human-like, and more effective. When people communicate, they don't just convey information, they express how they feel. Words like love, hate, excited, disappointment, or even emojis tell us far more than a plain text. Modern AI systems are learning to capture those emotions and sentiments. And when this understanding is applied to information retrieval, it helps systems return not just relevant results, but results that match the user's mode, intent, and expectations. Let's begin by first understanding what information retrieval really is. Understanding information retrieval. Information retrieval or IR refers to the process of finding and ranking relevant information from a large collection of documents. Traditional IR models such as TF-IDF or DM25 rank documents based purely on the frequency and importance of keywords. While these systems are efficient at locating documents containing certain words, they do not account for the emotional tone, the context, or the deeper intent behind the user's query. Modern IR, however, aims to go beyond simple keyword matching by interpreting both what the user is searching for and how the user feels while searching. For example, consider two people searching for best smartphones. One might be excited to buy a new phone, while the other might have had a bad experience with their previous brand. A traditional search engine would return identical results for both users, but an emotion aware system could recognize dissatisfaction in the query and filter out the disliked brand automatically. This shift from keyword based to emotion aware retrieval marks a significant advancement in how computers understand human language. What is sentiment and emotion analysis? Sentiment and emotion analysis are subfields of natural language processing, often called opinion mining. Sentiment analysis focuses on identifying the overall polarity of text, whether it is positive, negative, or neutral. Emotion analysis, on the other hand, goes deeper and identifies specific feelings such as joy, anger, sadness, fear, or surprise. This analysis transforms unstructured text into structured emotional information that a computer can interpret. For instance, the sentence, I love this phone, but the battery life makes me sad, contains both positive and negative emotions. A good system should detect this mixed sentiment, recognizing that while the product is appreciated, whether there is disappointment in one feature. Such detection helps improve the precision of information retrieval systems. It allows a search engine to understand that a user is looking for something emotionally satisfying, not just relevant by words. Why sentiment and emotion matter in IR. Integrating sentiment and emotion into IR enhances personalization, relevance, and user trust. When a search engine understands emotion, it can prioritize emotionally positive or appropriate results. For example, if a user searches best vacation spots to relax, the emotional cue is relaxation and calmness. A standard IR system might simply show famous destinations, while an emotion aware system should prioritize quiet beaches, peaceful resorts, or spa retreats that align with the emotional intent. Another example comes from e commerce. A user who types I am tired of overpriced phones that break easily clearly expresses frustration and distrust. By recognizing that tone, the system can recommend durable and affordable alternatives instead of premium options. Emotion recognition therefore bridges the gap between machine logic and human intention, making retrieval results far more meaningful. The workflow of sentiment and emotion analysis. The process of sentiment and emotion analysis follows five major stages. First, data collection gathers textual data from reviews, tweets, forums, or articles. Second, Text preprocessing cleans the data by removing noise, converting everything to lowercase, tokenizing sentences, and handling slang, negations, and emojis. Third, feature extraction transforms text into numerical vectors that can be processed by algorithms using methods like TF-IDF, word-to-vec, or BERT embeddings. Fourth, classification models, whether machine learning or deep learning, analyze these vectors to predict sentiment or emotion categories. Finally, evaluation measures how accurately the system performs using matrices like accuracy, precision, recall, and F1 score. This structured pipeline ensures that the model not only reads the text but also interprets it in a way that captures human feelings. Without proper preprocessing and feature extraction, even the most powerful algorithm will struggle to detect emotion correctly. Now, my friend Tribhuvana will take over the next presentation. Now we're going to discuss about lexicon-based approaches. They rely on predefined dictionaries of words that have associated sentiment values. For instance, the word amazing may have a score of +3, while terrible may have -3. Popular lexicon include Wader, Sentiment WordNet, and Affin methods. These methods are easy to implement and are transparent, as each word's emotional value is known in advance. However, they also have weaknesses. They struggle with sarcasm and context. For example, the sentence I just love waiting in traffic for hours is clearly negative, but lexicon system may wrongly interpret it as positive because of the word love. Lexicon methods are best suited for short, simple text like social media posts or quick reviews, and they often form the foundation upon which more advanced deep learning models are built. Machine learning approaches. Machine learning models treat sentiment detection as classification problem. Traditional methods include naive-based logistic regression and support vector machines. These models rely on handcraft features such as word frequency or n-gram. Deep learning models like LSTM and CNNs learn patterns automatically from text, capturing context and sequence. The most powerful models today are transformers, such as BERT, ROBERTA, and ExcelNet, which use attention mechanisms to understand context in both directions. For instance, the phrase, I don't hate this movie, has a subtle meaning. It's mildly positive, not negative. A traditional model might misinterpret it, but BERT recognizes that don't hate expresses weak positivity. Such deep contextual understanding has made transformers the standard for modern emotion analysis and significantly improved the accuracy of sentiment aware information retrieval systems. Now let's discuss about emotion modeling beyond polarity. Emotional modeling goes beyond positive or negative classification to identify nuanced human feelings. There are two major approaches: categorical model, such as Ekman's six basic emotions, and dimensional models, like the valence arousal dominance model. The dimensional approach measures how pleasant, intense, or dominant an emotion is. For example, joy has high valence and high arousal, while sadness has low valence and low arousal. This richer representation helps applications like mood based recommendation. For example, music streaming services may use emotion analysis to suggest cheerful playlists when the user expresses sadness or calming songs when stress is detected. Emotional modeling enables systems to connect human psychology with data science, bringing emotion and retrieval. Integrating sentiment into IR ranking. Once sentiment is detected, the next step is to integrate it into ranking algorithms. Traditional IR uses relevance scores based on term frequency. In sentiment aware IR, emotional scores are added as extra features. A common approach is score fusion. For example, final score is equal to zero point 0.7 into BM25 relevance plus zero point 0.3 into sentiment score. This ensures that results are ranked by both relevance and emotional positivity. Learning to rank algorithms such as Lambda Map or XG Boost Ranker can also be trained to learn the best combination of features automatically. In fraud as such, this means items with high positive sentiment rise to the top, while negatively reviewed products are ranked lower. In social media retrieval, emotionally strong posts, for instance, those expressing joy or outrage, are often ranked higher because they capture our attention. By combining linguistic relevance with emotional resonance, IR systems become much closer to how humans naturally evaluate information. Now let's discuss the applications across certain domains. The application of sentiment and emotion analysis in IR are vast. In e-commerce, emotion detection improves product recommendations by considering customer satisfaction level. Whereas in social media, it helps identify trending topics and track public opinions during events or crises. In entertainment, platforms like Netflix or Spotify use emotion recognition to suggest shows or music that fit a user's mood. In healthcare, analyzing patients' feedback helps identify dissatisfaction or emotional distress early. Whereas in customer support, emotion detection allows companies to flag frustrated users for faster resolution. A practical example is airline feedback. If most reviews for a route contains words like delay, rude, disappointed, the system identifies negative sentiment, prompting management to investigate. In short, emotion aware IR turns raw text into actionable emotional intelligence. Now I'm going to hand over the presentation to my friend Vardhan Veduri.
Here we will discuss about the evaluation metrics for sentiment aware in IR. Several benchmark datasets exist for training and evaluating models. The IMDb and ELB datasets are commonly used for sentiment classification, while GoEmotion provides emotion labels for over 27 categories. For aspect based sentiment analysis, datasets from SEM-Eval competitions are widely used. To evaluate models, classification metrics like accuracy, precision, recall, and F1 score measure predictive performance. For ranking tasks, IR metrics such as NDCG, MAP, and recall the rate K are used. In practical deployment, user centered metrics like click through rate, dwell time, and satisfaction surveys measure how emotion aware search improves real experiences. Combining quantitative metrics with qualitative feedback ensures both algorithmic and human success. Now let's talk about challenges and limitations. Despite great progress, several challenges remain. First, sarcasm and irony are notoriously hard for missions to detect because they rely on cultural and contextual understanding. Second, word change meaning depending on the domain. For example, cold can be negative in restaurant reviews but neutral in weather reports. Third, handling multilingual or mixed language text adds complexity as emotion expressions vary across languages. Fourth, bias in training data can lead to unfair results, such as associating emotional tone with gender or ethnicity. Lastly, overlapping emotions make classification difficult. Feelings like disappointment or frustration often coexist with sadness. Researchers are addressing these issues using transfer learning, domain adaptation, and explainable AI techniques. Yet the goal of perfectly human like emotional understanding remains one of the hardest challenges in artificial intelligence. Here we discuss about recent research and advancements. Recent research has focused on three major directions: transformer models, multimodal emotion recognition, and explainable AI. Transformers like BERT and ROBRTA have achieved record accuracy by understanding context in both directions. Multimodal analysis. It combines text, voice, and facial expressions to improve emotion detection. For example, a customer service AI may analyze both speech tone and the actual words used to detect anger and satisfaction. In explainable AI, aims to make these systems more transparent by showing which words or features influenced predictions. Large language models, such as GPT-4, are now capable of zero shot or few shot emotion detection without explicit retraining. This means they can understand emotional context in new domains. Instantly, a breakthrough for scaling emotion aware retrieval across multiple industries. System design and practical considerations. In real systems, sentiment detection can occur either at indexing time or query time. At indexing time, documents are pre processed and sentiment scores are stored as metadata, improving retrieval speed. At query time, real time sentiment analysis can adjust search results dynamically based on user mood or tone. To maintain efficiency, techniques such as model compression, distillation, and quantization are used to make large models faster. However, ethical issues are crucial. Emotion detection systems can unintentionally amplify bias, prioritize outrage, or invade privacy. Therefore, responsible AI principles must be followed: transparency, fairness, and user consent. Emotion aware retrieval should aim to enhance human experience, not manipulate it. The goal is to build systems that respect emotional diversity while serving people more empathetically. Now let's discuss the conclusion and future outlook. To conclude, sentiment and emotional analysis bring emotional intelligence into information retrieval. They allow systems to move beyond literal keyword matching and understand human tone, preference, and feeling. Emotion aware IR enhances personalization, builds trust, and improves decision making across domains. As technology advances, future systems will integrate semantic meaning, emotional awareness, and ethical responsibility into one unified framework. We can expect more multimodal systems that analyze not only text but also voice, facial expression, and psychological signals. The ultimate goal is to create search and recommendation systems that respond like a human companion, understanding not only what we say, but how we feel when we say it. Thank you so much for your attention. I hope this presentation gave you deeper insight into how emotion can shape the future of intelligent information retrieval.